Hello, Algebra 2. This video lesson picks up on the discussion we already had in class today about circles. And so if you were absent today or didn't understand the discussion today about circles, and in particular I'm entirely skipping and not including in this video lesson the discussion from chapter 10.1, which was about the distance formula and midpoint formula. So if you missed those things, make sure you get those notes from a classmate. Come in and ask me questions about it if you didn't understand it, but I'm going to assume that we're just kind of building on the discussion we had today, and mostly this video is to help folks through the homework assignment tonight in case that was confusing to anybody. So first of all, let's talk about this generic or standard equation for circles. The textbook, as far as I can find, doesn't ever actually come right out and say it this way. But notice our old friends h and k are back again, but in this case they're equally balanced. There's no h inside parens and k outside the grouping symbols, parens, square root symbol, whatever it is. They're both at the same level, and that makes sense because the circle is symmetrical. It's pulled both horizontally and vertically in equal amounts toward a center. So make sure you understand this generic equation or standard form for circles, where x minus the x value of the center of the circle squared plus y minus the y value of the center of the circle squared is equal to the radius squared. As long as you got this formula straight, then doing these first ones should be very straightforward. What's the center of this one? Well, there's no h or k shown. There are no parens even. So the center must be right there at 0, 0. On the one on the right, whoops, didn't mean to move that. But at any rate, the one on the right, let's get this back into place. It's going to all come awry. The x value of the center is at 0, but the y value is at 4. And notice that it's positive 4. Both h and k this time change their signs. So this minus 4 here becomes a positive 4. So there is that center at 0, 4. Now all you need to do is draw a circle around that center. Well, you know what, based on the standard form, this value off to the right here is r squared. So 4 is equal to r squared. That means r is the square root of 4, or 2. So you go 2 spaces in each direction from the center and draw your circle based on that. And there it is. You've drawn your circle. So you've identified the center and the radius. That's the center. The radius we just said is 2, and we've sketched the circle. I'm not planning to show you how to do every question in the homework assignment. That's what the homework assignment is for, but I wanted to make sure I at least did it at the beginning here. In future, I'm just going to get you toward your own ability to answer these homework questions. So let's move on then. Question 8. It tells you where the center is, and it tells you how long the radius is. Well, remember, there's your standard form of the equation. So plug in the center, 10, 12. The radius is the square root of 7. So r squared is the square root of 7 squared. Don't leave this as your answer, because the square root of 7 squared obviously can be simplified. And I hope you can figure out what the final version based on this is of the equation for number 8. I'm going to move on to number 12 here. In this case, I've given you the circle in graph form, and I'm asking you to tell me what the standard form of the equation is. Well, again, remember the generic form of that equation. Plug in the value of the center. Whoops, sorry, I didn't realize I stopped there. Plug in the value of the center here and here. Plug in the length of the radius squared. And if you can, please go that extra step and tell me what r squared actually turns out to be in terms of a value. So that's it for number 12. You should be able to do that based on those instructions. Come in with questions, though, if you have any about this, by all means. For number 14, I give you the center. It's at 15, 2. And there it is. I also give you a point on the circle. And there's 14, 5. Well, notice compared with 13, if you've done 13, you've already seen that it's an easier question to do. I'm giving you, helping you with the harder of the two. The radius now is going to have to require you to use the distance formula to calculate. You can see how long this side is, and you can see how long that side is. Figure out what the hypotenuse length is. That hypotenuse length is your radius. And once you have that, you not only can draw your circle, but you can plug all that information into the generic form of the equation and tell me what the equation of this particular circle is. So remember, you're going to plug in the center's x and y values here, and you're going to plug in r squared over here, and you're going to be done. That leaves us only with the last questions in the homework, and I'm going to show you how to do number 18. In this case, it doesn't give you the center. Instead, it gives you two different points that are on the circle. Fortunately, they're directly across from each other. They make a diameter. Well, if they make a diameter, then just in terms of the picture form, you know that the circle is basically going to look like that. You should be able, because I taught you today in class the midpoint formula, you should be able to find the midpoint between these two ends of the diameter. Once you've got that, you've got the center of the circle. You also, based on the distance formula, should be able to figure out what the length of the radius is. Plug those things into the generic form of the equation of a circle, the formula of a circle, and you should have your answer to question 18. So that's it for the video. Come in with questions. I'll be happy to go over these. And once we're done with circles, we're going to move on to ellipses. I look forward to seeing you next class.